Can anybody hear? Oh, okay, there it is. Hello, everybody. Thank you for staying for the last talk. I'll try to make it interesting. And I'll try to give you a demo at a certain point of something that I suppose you might find interesting. And then we go all together for beers, I suppose. All right, so I'm Branimir. I'm one of the founders of OriginTrial and the CTO of a company called Trace Labs. We're core developers of OriginTrial. And today I'll explain something which is a decentralized knowledge graph. How does that work with blockchains and Gnosis in particular? And what do we mean by this term, trusted AI? It's popping up all over the place. Just a quick kind of question. Does anybody know anything about knowledge graphs? Have you ever heard of knowledge graphs before? By a show of hands. There's like 2, nice, 3. Oh, awesome. That's actually pretty high. You wouldn't expect. So okay, I'll try to give a little bit of an explanation on it, but I'll kind of stay high level so that we don't dive too deep into the tech. But I'm here, and there's beers outside, so if you want to go really deep, we can go as deep as you want. I suppose after the talk. Okay, so moving on. What do we mean by this trusted AI? Why do we need it? Well, you've surely seen this guy. Geoffrey Hinton, the godfather of AI, leaves Google because once he invented basically LLMs, he got scared of his own invention. Very good reason. And the bigger reason is that it can very quickly start churning in a lot of very questionable information and can do questionable things. And one example you might have seen on Twitter is this lawyer who used ChatGPT to sort of come up with his case. And turns out that ChatGPT threw a bunch of non-existent things at him. So he used a bunch of quotations of different non-existing cases in court, and now he's actually in sort of trouble because of that, going to court to explain himself. So this is one example of how AI can very easily generate misinformation. Probably that person didn't have bad intent, like they wouldn't do this, they just didn't catch it, so they're probably in a rush. We're all in a rush with time, right? But even without AI, like the world has been full of fake news and misinformation all along for who knows how long. So really the key problem here is that when you add AI into the mix, the problem of misinformation becomes even worse. It goes even like basically exponential. Very soon AI is going to generate most of the content online. There's going to be some tipping point where more content has been generated online by AI than by humans. And then if we don't have some way to tame this, then we're basically screwed. So essentially one of the good things about us all here in Web3 is that we build on the primitives of trust. So we believe that an overflow of misinformation, really trusted data is what we have to rely on, and that becomes the cornerstone of everything. So I'm actually here to make a case that we're part of the third knowledge revolution. The first one was there to solve scarcity. So we had knowledge that was basically in a few places, some libraries, mostly churches, and we didn't have an easy way to replicate it. And then, boom, the printing press comes, replication solves the problem of scarcity, and essentially the humanity changes completely because we get the entire Renaissance and all of the amazing movements that started from there. And the world changed completely just because we could replicate knowledge easier. Then we got into the internet revolution, which solved the fragmentation problem through connectivity. People who are building all of the networks, the layers of the OSI stack, everybody from Ethernet, Bob Metcalfe, to Tim Berners-Lee, or the World Wide Web, or Web 1, or whatever you want to call it, up until to us now building Web 3. Basically, we're helping make things more connected, right? And then the final frontier right now in this new knowledge revolution is obviously trust. I'm surely preaching to the choir here. And the way to solve it with AI is to essentially infuse AI with decentralization. So I'm pretty sure that this is kind of completely fitting to this audience. However, I want to mention that this is indeed going to be a true revolution because we've never before had the opportunity to create large amounts of knowledge and content at scale that can be trusted. So I'm going to show how we at OriginTrial have been building this for several years. But one of the main pitch I want to make here is that knowledge is a new asset class. And the idea of being able to tokenize knowledge is going to bring an immense amount of value into the ecosystem, the planet. And actually, for those of you who know about knowledge graphs, maybe you know about them because most Web2 giants use them. Netflix, Google, Uber, Amazon, you name it. They basically aggregate all of the data about whatever we do, watch shows, buy things on Amazon and whatnot. They aggregate in these graphs. And because this is actually pretty mature technology, has been started by that guy, Tim Berners-Lee, over 20 years ago and has been developed through academia for a very, very long time. They actually managed to take that data and create immense amounts of value. And that's why we believe they are one of the biggest companies in the world today, because they had just like a ton of, not just data, but very organized data. And that is this transition that makes it go towards knowledge. So just if you haven't heard about OriginTrial before, we've been around since quite a while. Back in the day, almost 10 years ago, the three of us founders started a centralized proprietary business where we were helping track knowledge, actually connect knowledge about supply chains. So a lot of people still think about OriginTrial through that lens. 2018, we completely open sourced everything. We decentralized. We built this decentralized knowledge graph technology, which is a multi-chain technology I'll explain very soon. And it's now free to use. Anybody can run. So, and after that, obviously, the whole project grew. So it was a good choice. And today we have a few cases just I want to mention of different enterprises that adopted the OriginTrial. For example, the US retailers, Walmart, Target, Home Depot, through this association SCAN, they use OriginTrial to exchange knowledge about factory audits that actually cover 40% of imports in the US. This other case is Rail Travel Safety. Swiss Railways has been our partner for several years now. So they basically use OriginTrial through interfaces. Then we have a bunch of food and beverage companies and pharmaceutical companies also using essentially the decentralized knowledge graph to exchange and connect information. And it's all happening on several blockchains. So OriginTrial started in 2018 on Ethereum, expanded to Gnosis and Polygon, recently also to Polkadot. So it's basically a multi-chain decentralized knowledge graph. And what are these knowledge assets? These knowledge assets are basically, if I were to explain it the simplest possible way, they're knowledge NFTs. So you can create, mint your knowledge NFTs or knowledge assets. And when you do that, you obviously own the NFT. And with this ownership of the NFT, you're able to manage that knowledge. So that means I can update it. Let's say I create some sort of piece of knowledge that describes, I don't know, my shirt, and says like this shirt has been, worn several times and it's all sweaty because it's super hot here in Berlin. Anyhow, I can put all of this knowledge inside, and then I can maybe give it to somebody, and then I can also give the NFT or not. And whoever has the NFT has the ability to add additional knowledge inside. So it's like your Git repo, and you're the admin, right? And once you create and own your knowledge, then you can put it in the decentralized knowledge graph and make it discoverable. What does that mean? Well, you can discover it in different ways. I'll show you this interface that you see on this animation. Basically, this graph of knowledge behind the NFT, and you can do all kinds of interesting queries on it because it's a fully fledged database, basically Sparkle ready database. Sparkle is this standard, which is like Graph SQL, sort of. Kind of like GraphQL, but it's actually more descriptive and powerful. So you can ask anything, really. And finally, you can verify all of this information because when it was minted, you got basically a transaction on chain, you see who minted it, and you see if it was transferred to anybody, who updated the knowledge. So there's what we like to call a verifiable origin and information trail. See the pun. So anyway, this is basically kind of the key three value propositions of knowledge assets. And then once you have this, you can build very interesting trusted AI systems on top. And I'll show you one if I manage to connect the laptop in a bit. But essentially, you can consider this as kind of a decentralized knowledge database that sits on multiple chains, and whenever you want to publish your knowledge, for example, Gnosis, you can mint this NFT there and then use it. This is a standardized NFT, by the way. So what does this look like from like a super high-level architectural perspective? We have three layers. There's a consensus layer, a really blockchain layer, where we have multiple blockchains, and then this decentralized knowledge graph is layer 2. Think of it as kind of like an IPFS network. It's not a blockchain. It's rather a bunch of nodes that are peer-to-peer connection, and they are coordinated through this OriginTrial protocol that we've been building. We're currently in version 6 So we iterated quite a lot. We learned a lot on mistakes, and now it's actually pretty cool. And then on top of that, this sort of layer of knowledge asset applications, so applications that you can build that use this knowledge. And like I said, the key primitive is knowledge assets. We have this new type of identifier called uniform asset locator, which actually is a combination of a W3C DID, if you ever heard of decentralized identifiers, and this identifier in the graph. And what's cool is actually we're right now essentially developing the idea on how to incentivize growing knowledge in the decentralized knowledge graph. So we launched an actual blockchain for that on Polkadot. It's called OriginTrial parachain, as parachains on Polkadot. And the kind of the key utility of the token of it is to reward quality knowledge introduction into the decentralized knowledge graph. There's a lot of different technical use cases: search, for example, discovery, question answering systems, knowledge marketplaces, aggregation of knowledge, and so on, that you can use the tech for. So it's pretty widely applicable. And this is how a knowledge asset actually looks like. So on the blockchain, we actually have this NFT and knowledge state proofs. A state proof is nothing but a Merkle hash, basically, of the knowledge. And the knowledge here, if you've ever seen JSON LD before, or JSON, you've probably seen. Well, JSON LD is just like an extension of JSON, which the LD stands for linked data, and it provides some additional capabilities, including like adding schema and context to it. So basically, the knowledge is in some form. It can be this, but it boils down to this RDF. And then this is the UL, an example. It's a DID that has an address of the contract and the token that represents it, which basically then you can use to fetch this from the network. Then we also have a knowledge proof, which is basically a Merkle hash. So you can basically say, you can take an arbitrary size knowledge, it can be a megabyte, which you wouldn't be able to fit on a chain, of course, but you can provide proof to the chain that certain piece of knowledge or statement is included inside of this knowledge asset. And of course, all of that sits in the DKG index. So basically, you can spin up a node over the DKG and you can query all kinds of things in this traditional knowledge graph way. So we haven't invented anything. We just basically took all of the cool standards that W3C has been pushing through. And what's cool about this is these knowledge graphs are actually this old branch of AI. It's called symbolic AI. And what's happening now is this new branch, the neural AI, the large language models, and they fit really well together, actually. Symbolic has this, as you can see on the screen, has this sort of graph representation thing. It's highly structured. The neural side of it actually doesn't require structured data. You can throw at it text or images, and then it kind of learns. But when you combine both, you actually get some really, really cool things that you can do with machine learning. For example, you can add additional knowledge to the knowledge graph by predicting certain relations or completing the knowledge graph, as they call them. And that's why, for example, this graph machine learning is very useful for drug discovery, things like that, where you have a very specific problem that has certain structure. Actually, molecules are really good candidates to model with a graph. So social networks as well, and so on. Many other different types. But you'll see graphs everywhere, pretty much. So there's actually an ongoing integration of OriginTrial decentralized knowledge graph and Gnosis chain, and that's actually happening through a set of RFCs in the OriginTrial ecosystem. A couple of use cases that are particularly interesting here are really because the guys from Gnosis have been, I don't know if you've seen it, but they've been doing some very interesting things with the AI agents. The idea there is that AI agents vote and actually help prediction markets of Gnosis be more efficient. So instead of relying on people, you can actually run AI to go and buy outcome tokens. The idea here is that outside of them just searching things on the web and maybe running into some misinformation or getting tricked somehow, they can use this trusted knowledge in the graph and use that basically to verify the source of information and to have that as input for the decision. But also they can go the other way around, so we can essentially publish predictions about some event in the future from the prediction market into the knowledge graph, so you can make sort of a knowledge graph grow into the future, so you can query the future literally through a graph querying language. Knowledge assets can also be observed as sort of a semantic oracle. So instead of having an oracle where something puts like a number into a contract, like kind of current price of a token, you can actually have, let's say, an oracle that says, if 3 different issuers issued the same information, like, I don't know, that a certain building has certain energy certificate or something of that sort, if there's been multiple attestations, then execute a transaction. And you can literally just create these proofs, the Merkle proofs of these attestations. You can shoot them in a contract, and they can come from a knowledge asset, and basically you can verify the source and the actual content. An example architecture, just so we kind of have a high-level look, and it starts from the wrong direction. It starts from the right. So you have some knowledge source, and then you can create your knowledge assets. You can do it through a node. You don't have to do it through an OriginTrial node. You can consider it as an RPC. Some node somewhere needs to broadcast your message to the network. But let's say you do it through a node, and you have this knowledge bank application, as we call it. Essentially, what you can do is you can put a bunch of this knowledge inside your knowledge bank. You can also create embeddings, just as in this example I showed. And then you publish these knowledge assets on the OriginTrial DKG. That mints knowledge assets with stake hashes on, for example, on Gnosis. And from that moment on, you can go and discover. Basically, it's like a big search index. You can discover knowledge by doing queries, by knowing UALs, by finding new UALs in different existing knowledge that you have. And then, for example, some of the things you can do. You can determine intent of a certain question. I'll show you that in a second. I'm super quick, running out of time, so I'll show it in a bit. You can determine intent of a vector similarity search. Like you ask a question, I don't know, is this building certified? And then this intent you can use, for example, some vector database, but you can also figure it out from just the context, and you can do knowledge graph queries, you can do vector similarity search in combination, you can check the integrity of this on-chain, and then you can execute some transaction, whatever. For example, buying outcome tokens by the AI agents in Gnosis. And I'm going to try and show you one such an example of an application, just so I can plug in this HDMI quick of a chatbot, which we actually are working on for. It's not really a chatbot. I'm already saying it wrong. Okay, something's over there. Do you guys see that? It's like a no internet. Nice. Yeah, so sorry about that. Is it okay if we cross like a minute or two since I'm last? Sorry for this. Is it okay? I just need like maybe an extra minute over time. Okay, so I'm just gonna connect to my phone. Okay, so, or not. Yeah, there it is. Okay, so this is like a simple application, and I somehow triggered this question. What farm does LOT R152 this meat come from? Imagine me picking up a piece of meat in the store. We actually have this partner, and first app we built 10 years ago was centralized, old school app. You would scan this, and it would take from a SQL database the information about where does this come from, because we were getting this in real time, and we would show it to the people, and people were like, wow, 10 years ago scanning something with the QR code was unusual. But the problem was, ever since bigger supply chains and bigger problems were here, it was hard to get all of this information and to query it from a SQL database especially. That's kind of a technical thing. I can explain why graphs make a lot of sense. Today, imagine if I took a phone and scanned this product, and I come up with this interface that allows me to chat with a piece of meat. And I ask it, okay, where does this particular LOT come from? And it actually went inside of the graph and queried the graph. So you can see these graph statements here. It says product ID is that, and this is the farm owner, and it's kind of like a key value, but rather triple store. It's like actually has subject, predicate, object instead of key value. And when it finds images, it displays images and so on. And this comes from these source knowledge assets. And I'm going to open one just so you can see them. So this is the DKG Explorer. It's kind of like your blockchain explorer, but for knowledge assets. And essentially okay, I didn't click on the right thing, but I can open up any one. For example, this one. It loads these graphs, basically. This is a knowledge asset. I can zoom in, And I opened something different. I didn't open exactly the same thing. I opened the last one that was published on the network. But it's, as you can see, it's a graph of information. It has certain structure, and it has a bunch of knowledge assets that you can connect to each other. It has this NFT that represents it. I'm going to open up, this is basically a block explorer on OriginTrial parachain testnet, which shows you basically that this was created 4 days ago. And you can get all of this, like I said, all of this verifiable information of the source on the chain. However, I wanted to pick it out here. Aha. This one. Yes. So for example, you'll see here a bunch of connected knowledge assets. This is one knowledge asset, and if I open another one, if I click here, it fetches it from the network, and the graph pretty quickly grows into this very complex structure of different information. And this is, by the way, information on traceability, on the production, on the certification. But what you're seeing is really just where the data comes from in this application here. So when I asked the question, and I can ask it again, for example, I can ask, is this meat organic? If I click here, it's like I typed it. It actually goes inside of the graph. It understands my intent. It's looking for an organic certificate. And it actually says, OK, I found this product with this certificate owner, and this is the certification. If I click on the link, it shows me the link of the actual website. And basically has a bunch of information. So essentially, it helped me query the graph. It wasn't AI generating anything. It was AI extracting. Maybe you heard of retrieval augmented generation. Well, this is not even generation. This is just retrieval assisted by AI. We can also do retrieval augmented generation by basically just adding the LLM in the loop. So if I do the same question, is this meat organic? And basically just use this mode here, chat. The same information is just going to be sent to, in this case, in this example application, ChatGPT. So now it's not going to look like, well, let's say it's going to look nicer for humans. It says, yes, the meat is organic, but actually what we sent to ChatGPT was this wrapped in a prompt. We said, make this nicer for humans. And the whole point here being is that all of this information doesn't just come from some LLM, thinking because it's a really good guessing machine and figuring out what's the next word. It's actually looking into a set of knowledge that was created from a certain source or potentially curated by a community. Let's say you are a founder or somebody who's part of a blockchain community or a very deeply invested person in it. You could create knowledge assets about your community. You can have such an interface where people can ask things, but not get answers from some random people or random sources online, rather get answers from exactly the source, who actually the community, which the community curates and creates. So this is a very simple example. We have a bunch of examples on how to build such things through something, and I'll finish with this. If I can get back the presentation, that would be amazing. I have one more slide. Is it OK? Nice. All right. Actually, that's the last slide, but I'll show you one before, I hope, which is there's a dark slide. Can you show my dark slide, please? I promise it's worth it. OK, I'm just going to skip to it. Super quick. Yeah, so we're building this, of course, together as a community. So we're offering a grant program. It's called ChatDKG. Well, if you scan this QR code, you're going to get there. Basically, what you're going to see is a GitHub repo with a bunch of examples how to build what I just showed you with different technologies. We partnered with AI startups in the US, such as Milvus. They're one of the best vector databases around, open source as well. Google, folks from different areas. And we have several builders already building their solutions with OriginTrial knowledge assets and AI. Basically, the criteria is you have to build something useful, it has to be open source. And the grant is open, so you can feel free to apply if this seems interesting. And yeah, help us fight misinformation. I'll end with this quote. Thanks a lot, and sorry for exceeding the time.
Thanks. Do we have?
Thanks a lot for the talk. I have a bunch of questions, so I start
Shoot.
testing them.
Just
First of all, you mentioned knowledge marketplace. So what is your plan with pricing knowledge, and what mechanism do you have for pricing? Second is where do you store the data? And also there is all the links that you have also data on top of them, which are not necessarily in the knowledge asset. Where do you store it and how the query works? And third question, can we build personal knowledge graphs for this and build privacy on top of it?
all great questions. I'll try to be quick, but we can totally chat some more on in depth if you want, if we're staying later. So first one was knowledge marketplace. So we've done a lot of pilots, actually, with prototyping knowledge marketplaces. We've done things which are based on trusted knowledge exchange. So meaning you can create knowledge assets which have private knowledge in them. How can you do that? Well, basically, because knowledge is just a bunch of triples, it's literally key, value, value, or rather value, 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 3 values. You can split it in two sections. If you have a knowledge bank, let's say you as a person run this knowledge bank, or sometimes we call it knowledge wallet in the context of knowledge marketplace, you could put these private triples inside. However, when this hash gets produced, they get included in the hash. So you can prove to me that at some point, basically this was part of your knowledge asset, even though some data was private. What's interesting to put in the public domain is really for this discovery line, the first line that starts from the agent. Because that's something, obviously, if you want somebody to discover something, like you search on Google, some indexing material has to be there so that it can be discovered. But you can put a lot of stuff, private stuff. Actually, most of the enterprises, they use this feature of private knowledge in the knowledge assets all the time because they are not allowed to share a lot of the information publicly. So for some of them, the knowledge assets just contain a little bit of metadata in the public domain, but there's a ton of it in the private domain. And having that said, this is obviously a prerequisite for knowledge marketplaces. You cannot sell something that's public, right? What we've been building is basically smart contracts based on, we found a protocol developed by a couple of universities. It's called FairSwap. We didn't invent it. The guys basically proved that it works. And it's a really cool system which uses something called proof of misbehavior. So let's say I have knowledge in my private knowledge bank and you want to buy it. You would lock some tokens in the Solidity contract. Once my node, knowledge bank, sees that you did it, it sends you an encrypted version of this knowledge, and then supposed to send you a key, actually, to decrypt it. The key is supposed to be sent to the contract so the contract can understand did I try to trick you or not, basically. And if by not being able to decrypt the knowledge, somehow I kind of sent you lorem ipsum bullshit, you would be able to send this proof of misbehavior to the contract that would understand, this is actually not what was supposed to be solved. So we have some of these primitives pretty well tested. They're already in Solidity. And we have it in our roadmap to go into productive knowledge marketplaces within a relatively short timeline. So likely happening already, some of it happening this year and most of it next year. So this is definitely something that is a big next step for OriginTrial. Again, a lot of code we have a bunch of info, so I can share some more later. What other question did you have? You have privacy, you had knowledge marketplace, and
I guess I will catch you afterward.
okay, awesome. Thanks a lot. But happy to talk. It's all great questions. There's
Okay,
2, 3.
Thank you.
Okay.
I'm sorry, but I'm sure that you will
Absolutely,
be pleased.
guys.
Exactly.
I'm here. We just need to get something cold because, as you can see, I'm like the sweatiest person in this room.
Okay.
All right.
So thank you all for your time. I hope you have enjoyed the talks and see you tomorrow.